Hello, I'm about to present a visual technique that can facilitate certain calculations and help memorize formulas. This technique, I call it the T pyramid. It looks like this. We trace a T. The pyramid can be seen like this. And we will put values in these three places, for example, A, B, and C. We will see in which situations we can use this technique, why it works, how. Lastly, there will be some training exercises. There are two main applications that work almost the same. First, we have systems with plus and minus. It's for situations with one dimension. We can call this unidimensional systems. Then there are systems with multiply and divide signs for situations with two dimensions, so bidimensional systems. In the unidimensional systems, we can use these rules that are often taught in school. If A equals B plus C, then we can deduce that B equals A minus C, and that C is equal to A minus B. In bidimensional systems, there are similar rules. If A is equal to B times C, then we can deduce that B is equal to A over C, and that C is equal to A over B. These rules are commonly learned and used, yet finding the right symbol, where to move what part, can be time-consuming, or we can make mistakes. The T pyramid makes them visually intuitive and provides a way to double-check. Why does this system work? If I give you, for example, 7 equals 2 plus 5. This can correspond to a real situation with a path where we advance by 2 meters, then by 5 to reach 7 meters. Here we have 2 meters. And here we have 5 meters. And all this amounts to 7 meters. If we assign A, B, C in the equation and in the drawing, that's how it looks like. We can see that 2 and 5 combine to form 7, and that 2, in fact, is 7 to which 5 has been removed. In the same way, 5 is 7 missing 2. So, in this system, we identify two elements that are combined, B and C, to form a third element, the global A. And we understand that if we consider the global A element, and if we decompose it somewhat by one of the combined element B and C, we end up with the other combined element. So we can deduce any number from the other two, either through combination or decomposition. That's the basis, and it allows us to build the pyramid. So, to build this T pyramid, first we draw a T. Then we take the two elements that are being combined and put them below. Here it's 2 and 5. The global number that results from their combination goes at the pyramid top. Here it's 7. We can see that there is a hierarchy separating the combined parts below from the global part at the top, hence the pyramid shape. Now, as we know that the combined numbers are always at the bottom, while the global number is always at the top, we can retrieve the school rules thanks to this pyramid by isolating one angle and observing what remains. If I separate the top of the pyramid from the rest, I end up with two numbers at the bottom. I see that they are at the same hierarchical level, so I know that they are the ones that combine together. I can imagine a plus sign here. So the pyramid tells me the top equals the sum of the bottom. Then if I separate the value of a side and look at what's left, I see that there is a hierarchy. One number is up, the other is down. So I know that the top number is the global one, that it's being decomposed by the number below it, and that the sign between is minus. For the other side, it was the same way, it's symmetrical. So the pyramid tells me one side equals the top minus the other side. And now we know how to read a pyramid. Back to our example, we can express each value according to the two others. We start with the value at the top. We know it equals 2 plus 5, the combination of the bottom numbers. For the bottom left, the 2, we know that we have a decomposition, so it is the minus symbol. For the 5, it's a decomposition too, of the global top value by the bottom left one. So it's also a minus. In the end, we have 2 equals 7 minus 5, 5 equals 7 minus 2, and 7 equals 2 plus 5. For unidimensional systems, we can synthesize this way. This was for unidimensional systems. For bidimensional ones, it's almost the same. But careful, mixing both systems in the same pyramid doesn't work. It's plus and minus or multiply and divide. Now let's see bidimensional systems with 8 equals 4 times 2. It's like putting down 4 rocks twice. The global value here, A, would be 8 and B and C would be 4 and 2. In our drawing, the total will be 8 rocks, so A equals 8. The B will be here, it will be 4, and the C will be here, it will be 2. In this bidimensional system, the combination is not a sum, but a multiplication. Let's add this to our recap drawing on the left. And the decomposition here is not a subtraction, but a division. Let's make this system's pyramid. We draw the T, we put the global value 8 at the top, and at the bottom we put the two combined value 4 and 2. Now, how to read this? How do we express each value according to the other two? Isolating the top value 8 leaves 4 and 2. We know that the bottom parts are the combining ones and we're in 2 dimensions, so the signs can be multiply or divide. Here it's a combination, so it's multiply. Then the bottom left 4. Two numbers remain at different height, so it's a decomposition. In 2 dimensions, decompose means divide, so 4 equals 8 over 2. Finally, for the right side 2, if we isolate it in the same manner, we see the other numbers on 2 different levels, so it's a decomposition. The system is bidimensional, so we have a division here. Let's synthesize like before. Here we have a multiplication, and here we divide. And that's how the system works. At first, we need to trace the pyramid. After a while, we can just see it in our minds. Put the global above, the combined below. We can see the system, so we know what to do. Let's train with some exercises. The goal is to express the circled number according to the two others. First, we create the pyramid, then we read it. We will solve the first ones together. To express 23 according to 9 and 14, we first trace the T of the pyramid. There's a minus, so there's a decomposition. In decompositions, the global value is always left of the minus, or divide. Here it's 23. We write it at the top. The remaining ones go on the bottom. Here we want to express the 23. We isolate it, 9 and 14 are left at the bottom. They're on the same level, so it's a combination. So 23 equals 9 plus 14. Second example, we draw the T again. We know that it's a decomposition because there's a minus. We know that left of the minus is the global value, so we put 150 at the top. Then the two remaining numbers are the combining ones. Now if we isolate the 42 value to see what it corresponds to, we find 150 at the top and 108 at the bottom. They are not at the same level, so there is a decomposition between the two. And that's what the reasoning is. Last example, we make our pyramid again. This time it's a plus, so we have a combination. The values around the sign go out the bottom. 1.7 will be the global value at the top. Then if we isolate 1.5, we see 1.7 and 0.2 at different levels. So there is a decomposition between them. We can write that 1.5 equals 1.7 minus 0.2. Now I invite you to hit the pause button and do the bidimensional exercises by yourself. Good luck! Here are the results. Hopefully you got it right. The trick was to do just the same thing, but considering the pluses as multiplies and the minuses as divides. And that was the technique of the T pyramid. I will show in another video how I use it at college level to facilitate algebra calculations and the memorization of formulas. That's it. Thank you for watching. I hope that this will help you.